Okay, so let's see first what do we remember from class and to learn about the type of forces that we are dealing with. First of all is the force of gravity. Right? How do we draw the force of gravity? Is an arrow that points down, right, toward the center of the earth. That's it. That's always the case. There's nothing different about the force of gravity regardless of the situation. For all objects on Earth, the force of gravity points down. Okay, then we learn about the force of tension, Ft. Now, the force of tension is along the string. The way you draw the force of tension is you have to imagine that if you have a string, right, and you bring nearby a pair of scissors, right, and if you cut the string, what happened with the object, right? Then if the object moves from that position, therefore there has to be a force that holds it back in the presence of the string. In the absence of the string, it's going to do something else. So the force of tension, it is along the string, but it can be in two directions along the string, and we have to be careful to choose which one the force of tension it's acting on. Okay, let's move on to the other forces. Let me add another window here. What else do we have? We have the normal force. Now, the normal force comes at the contact between two objects. Right? The most common typical situation is if you have an object sitting on a table or anywhere, right? If the table is missing, okay, you remove the table, the object is gonna go down, right? Therefore, there has to be a force that holds it back in the place when it sits on a table. And that is the normal force. Okay? What happens if it's something at an inclined plane? Right? Let's see in this situation. The normal force, let me pick a different color here. The normal force is going to act perpendicular to the surface, right? This is something that we have to remember. The normal force is perpendicular to the surface. So actually, where can I pick up the color? No, I think it's from here. Yeah, here we go. Right, normal force is perpendicular to the surface. Okay, so we covered the force of gravity, force of tension, the normal force. Next, okay, let's do this. Let's say we have the force of friction. The force of friction. It is also another contact force. And what we have to remember has the direction is opposite to motion. Right? So if the object here, let's say it moves to the right this way, okay, if the object is moved to the right, let me pick here another color, we draw the force of friction to the left, right? If the object is moving to the left, we're gonna draw the force of friction to the right, right? So the rule of thumb is force of friction is opposite opposite to motion. So we have to think about it, which way is the object moves in order to draw the force of friction in opposite direction, right? And you remember the force of friction equal mu, coefficient of friction, times the normal force. Okay, what other forces do we have? Now, you remember we talked what happens if there is a force that involves a spring, right? A spring can be horizontal or vertical, right? If you stretch the spring, right, and you let go, what will happen? It will come back to its original position. Why? Because there is a force embedded inside of the spring that makes it come back, right? And what we can do with the spring, we can stretch, or we can compress, right? If we stretch the spring, the elastic force we're gonna try to bring back. So it's opposite to the stretch. If we try to compress the string, the elastic force, we're gonna try to bring it back. So in both situations, the elastic force, it's opposite to the action, right? This is why we have in the formula that negative sign, which is the constant K times the stretchiness or the compression. Okay, so I think we cover all the basic forces. We have force of gravity, the normal force. Let me review a little bit quick again. So we have the force of friction, we have the normal force, we did the spring. What is the one in the back? We have the force of gravity, force of friction, looking for the normal force. Actually, I think I should be doing it this way, right? As a review, force of gravity, spring force, there is, the normal force. Okay, now let's try to put them to work in different examples.